안녕하십니까? 저는 경희대 보철과의 노관태입니다.
Hello, I'm No Gwante from Prosthodontics Department of Kyunghee University. Today, we are going to look at screw loosening and fracture causes and solutions. These are the topics I'm going to cover today. I'm going to talk about problems related to screw loosening and what are the reasons for screw loosening and how can we resolve screw loosening and fracture. Now, screw loosening, there's a difference by literature, but if you look at the Goodacre article, says the screw loosening happens by about 7 to 6%, and fracture happens by 2 to 4%. Another studies also said that screw loosening happens more about 5 to 45% for single implant, and screw loosening happens within the 6 months and more males than females. Now, screw loosening rather than the loosening itself, additionally, it results in biomechanical problems to lead in implant failure, and that is why it is important. In various studies, screw loosening and implant fractures, they say, are related. So, screw loosening ultimately could result in implant failure. So, to prevent screw loosening, you have to know what to do. And in many literature, it says 67% as much as 96%. They say screw loosening is related to implant failure. Now, screw loosening do cause additional problems, and as I said before, it wobbles prosthesis, and as a result, around implant plaque can be deposed, and also screw abutment and implant could fracture, and as a result, marginal bone resorption could happen. Now, screw loosening, to identify that issue, you have to understand mechanism of screw. So, screw tightening means with the screw friction force, abutment and implant is not maintained. It's with the screw, when you tighten it, usually in the clockwise direction, then a screw is metal, but it elongates. And that elongated force reaction to that, the abutment and implant comes together. So the reaction to that elongated force, we call it as a preload. And preload is about 400 newtons. And preload compared to occlusal force, if it becomes bigger, the screw stays in place without becoming loose. And typically screw, about 10 micron is the elongation length. So this is how the screw is tightened. So you have implant and abutment, and with the torque wrench, you tighten the screw in the clockwise direction. As a result, you have such a contact, and depending on the torque, the screw elongates in this direction, and that is about 10 microns, and as a reaction to that, abutment and implant comes together, is connected. Now, preload, there are different factors that affect that. Typically, torque plays a role, and also repeated tightening is what you need to do. You have to comply with the protocol to prevent screw coming loose later on. So just tightening with hand once or just giving one torque, then it's very likely that screw will become loose. So you have to abide by protocol. And another important thing is the torque's value needs to be maintained, and I'm going to tell you how. And screw surface is also important, so I'm going to talk about these topics today. Basically, if you tighten with hand, about 10 to 15 newtons of the torque would be loaded. Of course, it depends on the person, and it depends on whether it's anterior or posterior. Posterior, it's a bit hard to access, so compared to anterior, it's hard to give torque. But if it's anterior, if the adult male pushes tightly, they say it's about 12 Newton. So there's a 12 to 22 newtons are the force you put in hand. And but to maintain preload, you should not only do by hand, but use the torque wrench or torque driver. And you could do it in the ratchet Y or spring type. So 30 to 35 newtons of connection force needs to be applied using such a driver. But by screw, the connection force will be different. By implant, the screw diameter is different. That is why you have mini implant and regular implant, and mini implant has a thinner screw. And thinner screw means, compared to regular screw, you cannot give the same force. Maintaining preload means screw needs to be elongated, and in reaction to that, you maintain clamping force. So just giving force does not mean that it will become less loose. Metal, if you think it as a spring, then spring, if you elongate too much, it deforms. Same with the metal. If you give too much force in clamping, the metal elongates and deforms. So typically, the 75 to 85% of tightening compared to the stress level given. So because if you give too much force, there could be deformation of the metal. So in mini implant, if you give regular torque, the screw can be deformed because screw is thin. And prosthetic screw is also thin. So 20 Newton is what you give as a load. So you have to know how much torque to put. Now, this is the probably what you know, probably learned in the textbook. So as you put force, there's deformation, but if it goes beyond certain level, then the deformation becomes permanent. Same with the screw. If you give too much force, like 35 Newton needs to give them, but if you give 6 to 17 Newtons, then screw becomes deformed, cannot be used. So you need to know about this beforehand. So when you tighten screw, just if it ends with once tightening, it will be good. But screw, abutment, and implant, if you look at with the microscope, it has a very delicate or minute roughness. And if you tighten screw, the roughness becomes dull and the surface becomes smooth and becomes a bit loose. So when you tighten the screw and metal, as a result, becomes a bit loose, and such a phenomenon is called embedment relaxation, or we also call it settling. So because of settling, now, implant and screw, all surface that comes contact, settling happens. So when implant touches abutment or implant is connected to the screw, and where abutment and implant comes into contact, if the position changes, then the elongation of the screw, that length would be different, hence changing the preload. And to prevent such a screw becoming loosening in the beginning, you have to do retightening. And about retightening, everybody agrees, but time interval for retightening, there seems to be different opinions, but they all agree at least 2 times or maximum 3 times of retightening in the beginning is important in preventing screw loosening. Now, there are different literature, so that more than 3 times of retightening, not much changes, but a minimum up to 3 times of retightening, they all say is good. That seems to be how it's reported. And after tightening time interval is given, then they say retighten. This is because in the beginning, because of the settling effect in the beginning, and also when you retighten internal conical implant, has a bit of this changes in abutment, there's a retightening is necessary. And when you compare retightening versus no retightening, 30 newtons, then after 3 hours, and the torque, the loss rate becomes different. Now, this literature is 2 years ago published in JPD, and if you have time interval and tighten 2 times is conventional method, and this study 10 minutes of time interval versus no time interval, and also tightening just once, and after tightening, counter tightening, and then tightening again, and repeating that twice. Sample size all 10. They did an experiment, and if you see, compared to once tightening, others have higher value, but the highest removal torque value came from the 5th approach: tightening, retightening, tightening, retightening, and then tightening again. Had the tightening, counter tightening, tightening, counter tightening, and tightening again. But what's interesting is that 10-minute time interval and no time interval, there is not much of a difference. It's a bit different than other studies, but this here gold-coated screw was used, hence additional experiment might be necessary. But here, what is again interesting is that tightening and loosening and tightening, loosening and tightening again had the highest torque level. So this, I think, means the settling effect comes after a certain time, and that steps accelerate settling effect, reducing friction between metal, and reducing friction means the tightening torque is given to the screw fully, elongating the screw. So hence, wear happens in the beginning, making the surface more smooth. Of course, as I said, further additional and more studies would be necessary to be sure. Now, as I said, when you tighten screw, you have to do at least 2 times. And this is for internal conical connection, settling effects it also happens between abutment and implant. And here, if you have settling effect, that means the abutment comes down a bit, and about 4 to 5 microns. Now, abutment sinking down means the elongated screw becomes shorter. And I said shorter, if you put 30 microns, 10 microns is the elongation, but with the sink down, the abutment sink down in the beginning, screw becomes shorter, then preload actually is reduced in the beginning. So to offset, implant screw must be at least tightened 2 times. So tightening, torque, and abutment sink down was studied by Dr. Kim rather than doing by hand. If you push by 30 newtons, then about 30 microns abutment sink down. So 30 to 40 microns, the abutment sinks down. And that is not a small volume. 30 to 40 microns, it's about a thickness of 2 film. So if you have screw type of prosthesis, once tightening, for example, 10 microns, and you finish occlusion and tighten with the ratchet, the level would actually go down. And with the retightening, abutment comes down again. So at least 2 retightening steps would be very much necessary. And in using implant, in axial direction, there could also be sink down. That amount is different by study or literature, but here it's from Dr. Lee. It says this is about this much of micrometers has been reported in this study, and in usage, the abutment sink down. It says it happens a lot within the first month, and if you even consider then you retightening after 1 month could also be helpful. So repeated tightening is very important. And if you are using temporary, then when you connect abutment and in using and also taking impression and delivery restoration, tightening in different steps will be necessary. If you do same day delivery, you also retighten again, and the abutment of the prosthesis, you put load beforehand, then tighten again, might be also necessary. Now, to give tightening torque, as I said before, you need to use torque wrench, and this spring type torque wrench can be used for tightening. So you hold for 10 seconds, and that's the recommendation. So spring type torque wrench, after time, torque becomes, they say, it's reported becomes weaker. So every 1 or 2 years, you have to check whether torque has not been reduced. So you have to do calibration. And torque limiting device, you could also, but the spring elongates, and when you clean it, it could also reduce torque. So the have to calibrate regularly and do regular maintenance and checkup. Now, screw surface is impact the preload. Of course, the torque that you put on to become it needs to have less friction. For the extension, for external implant, the screw played a more important role, and to reduce friction of the screw, template coating and gold coating was done, and now OSSTEM's ebony gold screws is also coated, and this coated screw is very thin, and the torque that we load extends or elongates the screw, creating better preload or increasing preload. So if you have more preload, then it's reported in various researches, but that whether it has a meaningful difference in screw loosening, there seems to be a different debate, which means additional clinical study in this area would be necessary. So again, in screw tightening, what are the clinical considerations that we need to be mindful? Now, screw torque for the internickel conical implant affect vertical height. With the settling effect, the abutment sinks down in the beginning, and depending on the torque, abutment sinks down in different levels. So you have to consider that and do the retightening. And with the time, settling is something happens, abutment going down by 2 to 10 microns could happen. So periodically, torque needs to be put on. So that type protocol needs to be used. And stronger does not mean better. So 75% of the force. So you only do as much as to the level recommended by the manufacturer. So if you go too high, it doesn't really help in terms of screw loosening or in other areas. And you also have to regularly check the torque limiting devices, do the calibrations of those devices, and coated titanium screw improves the preload in the beginning. And hex driver size, hex size is different by implant, so you have to be aware of that. And the screw, sometimes it comes dull with time, so you have to check that. The X driver. So if it becomes dull, you have to change to new product. And if you use that for tightening, even after becoming dull, the screw head could wear down. It tightens, but you cannot counter tightening or loosen again. So again, you have to check how much wear happened on a regular basis. Now, screw loosening. There are different factors that come into play. basically the screw maintaining preload and putting the clamping force. So two are connected. But compared to the connecting force, the occlusal force or other forces is stronger, then the screw would be impacted and screw become, as a result, loose. So screw loosening and fractures, risk factors, there are different ones. There are implant-related factors, angle, position. If you have small diameter implant, then the external wall thickness could also have a play in the loosening. And if the abutment is not correct, it could also become loose. And if you don't abide by the right protocol, there could be also loosening. And for the interconnection type, the sink down should also something that you need to consider. And as occlusal factors, occlusal interference, cantilever contact, and patient habits like bruxism and clenching could also result in loosening and fracture. So let's look at some of them. Now, cantilever, if you load that 4 milli implant in the center, the content that is beyond 4 meters, the resistance becomes weaker and it's not really good. And compared to the contact here, if there is a contact point for 6 millimeters, then 35% of the reduction would be the result. So more than 4 millimeters of contact point. So for implant itself, become a force for cantilever. So if it's beyond 4 millimeters and that is contact point, then mostly it's molars. Premolars, it's not so. So if the implant is in the center, it doesn't work as a cantilever on the premolar side, but on the molar side, you can actually put cantilever force. For natural teeth, for 10 to 9 for the molars, but for the mesial and distal, if you have distal and more than 2 implants together, you have to reduce the distance, and the embrasure space can be reduced to reduce also food retention. So because of that too, 6 and 7 is the implant crown I did. So this size here compared to natural teeth, if it's side by implant, the side needs to be smaller. Now choosing implant diameter also plays a role in the loosening of screw. The external different things are reported in the fatigue test. It says that stronger compared to 4.0, 5 and 5 in the fatigue test, they have better results. Hence, in implant, when it connects to abutment, external implant and tissue level implant SS, and also internal connection type TS. Here, this part about 3.2, 3.5 is the connection area and abutment, platform switched, and external and tissue levels. A strong area becomes abutment area, and there is more connection and can be more resistant to the cantilever. In the finite element analysis, it shows same result. If the occlusal force is strong and choose strongly, then with the single implant rather than internal connection type, this type of tissue level implant would be, in terms of screw loosening, would deliver more favorable prognosis. So again, depending on your clinical situation, you just choose the best implant for that. Now, implant and screw loosening and fractures, again, different factors come into play. and you also need to understand mechanics of the screw. So we looked at some areas, and additionally, if screw becomes loose, using ESR kit and other resolutions that you could apply through the offline practice hands-on, I think we can learn more. So I hope to see you then. Thank you very much.
같이 또 경험을 공유하고 실습을 할 수 있는 시간이 됐으면 좋겠습니다. 네, 경청해 주셔서 감사드립니다.